It's taking a few seconds to prepare, but we know that it has a delay here. So, and I believe we're live on YouTube now. So, hi everyone. I'm going to start the webinar and let all of our participants in. And then Michelle, I'm passing the host duties over to you. And this would be a good time for everyone to just start chatting. How's everybody doing today as we're getting ready to begin?
We're fantastic and excited about today's activities.
It's exciting. It's almost as cold as it is on Mars.
It really is. Snow in Houston.
Oh, well. Awesome. Thank you, Lisa. Let's get this ball rolling. Can everyone tell us where are you from? Go ahead and drop it in the chat box. Where are you joining us from? We would love to know.
And yeah, please select panelists and attendees so that way everyone can see what you're writing. And is there anyone who isn't expecting ice or snow? Patricia.
That's one of the great things about living like 5 miles from the ocean is everything just turns to rain before it gets here.
Well, that's usually the case in Houston. Not this week.
No snow in Georgia, according to Jack.
Ontario, Canada. So far, Julie, you're the farthest one. We'll see who else is from pretty far away. See if anyone joins us from over an ocean. Arkansas, New Mexico, Charleston, Ontario, Canada, Texas, New York City, Virginia, Georgia. Welcome, everyone. Sherelle, do you want to talk a little bit about cameras and about promoting people?
Absolutely. Well, hello, everyone, and welcome. We're so excited about the presentation today and the engagement that's going to happen, but we have to, some house rules and housekeeping things. So if you would like to be able to share your camera so you can be a part of the demonstration, just go ahead and raise your hand and we will promote you. We'll promote you to the stage. So go ahead, and if you're wanting to share your camera, please note everyone that this is being recorded and we are live on YouTube. So if you would like to be promoted to the stage, please just raise your hand and we will promote you to the.
Oh, Sherelle, I think you went on there.
So so far we've got a couple of.
Awesome. Also, ladies and gentlemen, we want you to be aware that we have closed captioning. So if you're seeing the words that I'm saying on the bottom of your screen, you can actually select live transcript and hide those things if you do not want them and do not want the closed caption on your screen. So you have the privilege of hiding that. All right. Awesome. Let's continue.
So Michelle, can you go ahead and promote our two attendees who are volunteering to share their cameras for this? Lisa and Sonia, could you please promote them to panelists? So our participants will see a couple of other participants on screen too during today's program.
And by the way, I didn't mention this, but we are on YouTube Live. So our channel that we're streaming to right now, Lunar and Planetary Institute.
And we're so glad to have everybody here today. And it's just about time to get started. Sherelle, what do you think? Should we go ahead and begin with a poll question?
Absolutely. Let's just jump right in here. We want to make sure that we're respecting everyone's time. So let's go ahead and get started. Miss Michelle, would you please bring up our first poll question?
And
Quite
so
interesting. Go ahead, Kristen.
Sherelle, please take it away. Let's see what people think.
All right. If you could take a trip to Mars, would you? Go ahead and give us your answer to those poll questions. And then tell us about yourself. Click any of the choices that is appropriate for you. And while we're asking everyone to participate in the polls, I would like to swing those two questions to our scientists as well. Dr. Filiberto, Dr. Craig, would you take a trip to Mars? What are your stipulations?
I would say absolutely.
I would say probably not, but I am happy for people to go there and get me samples and bring them back for me.
Okay.
And let's go ahead and give everybody 5 seconds to finish answering the poll question here. 5, 4, 3, 2, 1. And let's go ahead and let's take a look at what everybody said. So it looks like about half of you said you'd have to think about it, but a few of you absolutely said yes, and some of you said probably not, or you have no idea. And then among those of you who are with us today, so a lot of you have heard, about half of you have heard someone talk about Mars before, and more than half of you plan to watch the Mars 2020 landing this upcoming week. About a quarter of you have met a NASA scientist or engineer before. And after today, all of you can say that you have met a NASA-funded scientist before. And a lot of you are interested in becoming scientists. Thank you so much. Everyone is able to close it themselves after they're done looking at it. There's a little button there that says close. And I also want to remind everyone, if the captions are distracting you, you can go ahead and turn them off yourself individually. There's a little button at the bottom of the screen. If you put your mouse on the bottom, you should see the option to turn off the closed captioning for yourself, where you click on where it says CC live transcript and click on hide subtitle. So that way you can not have it distracting you. Sherelle, what's next?
All right, ladies and gentlemen, let's go ahead and get started with our, we have another poll question at this time. Miss Michelle, would you please put up the next poll question? All right, so how long is the trip? How long would it take the Mars 2020 mission with the Perseverance rover to reach Mars? Let's see what our guests know. And in comparison, how long does it take a spacecraft to reach the moon? Go ahead and answer those two poll questions for us, please. And then we'll dive right into the introduction of our scientists. All right, we're gonna answer in 5, 4, 3, 2, 1. All right, let's see our results.
Woohoo! So, wow, 71% of you said it would take about 7 months for the mission to get to Mars. And about a little more than half of you said it would take about 3 days to get to the moon. Dr. Filiberto, Dr. Craig, do either of you want to add anything to that?
No, that's right. It takes a lot longer to get to Mars because it is a lot farther away than the moon is.
Sherelle and Michelle. Michelle, would you mind going ahead and moving us to the next slide, please? And Amanda, Dr. Amanda Smith Hackler, would you please talk a little bit about this and how it relates to what's going to happen this week?
Sure. Thanks so much, Christine. Well, howdy from Houston, Texas. It's a cold and dreary day. I hope it's a little warmer wherever you are. As Christine said, my name is Amanda Smith Hackler. I'm the Director of Education for the University Space Research Association, or USRA. So USRA's mission is to advance space and aeronautics related exploration through innovative research, technology, and education programs that includes the STEM Action Center. So the STEM Action Center is actually intended to serve K through 12 students in Maryland and beyond. And we offer an array of programming intended to strengthen interest and retention in STEM degree and career fields. So today we have an extremely exciting program lined up for you. But first, I want to make you all aware of an event you don't want to miss. So make sure and mark your calendars for February 17th. That is next Wednesday. So in collaboration with the American Museum of Natural History, we'll be hosting an online interactive and immersive program that will feature astronauts Mary Cleave, Alvin Drew, and Paul Richards. The American Museum of Natural History uses this really cool data visualization software to simulate deep space exploration. So I encourage you all to participate, and if you have additional questions, please do visit our website at stemaction.usra.edu. Thank you, Christine.
Thanks. Let's go ahead, Sherelle. Let's get started here with our discussions.
Awesome. Yes, so let's go ahead and we have the images, and actually we haven't got a chance to visit our scientists yet. So would you please start to introduce yourself, Dr. Filiberto and Dr. Craig? Take it away.
Okay, sure, I'll start. So my name is Dr. Patricia Craig. I actually used to work at the Lunar and Planetary Institute in Houston. I now work for the Planetary Science Institute. They're based in Arizona, but I myself live in Myrtle Beach, South Carolina. So what I do is I help operate. I'm not an official team member on the Perseverance rover, but I am an official team member on the Curiosity rover, Perseverance's older sister. So what I do is I help operate one of the science instruments on board the rover. We monitor health checks, we analyze rocks, you know, and help collaborate with other science team instruments to study Mars.
Hi all, I'm Dr. Justin Filiberto. I am a scientist at the Lunar and Planetary Institute. And if you can see my screen behind me, I study rocks on the Earth that look like and can tell us about features on Mars. And so one of the things I look at, you can see that big fin that's nice and black, that's lava that came in interaction with those reddish rocks that look like the same color as Mars. And we look at how the lava and the rocks interacted to produce habitable environments on the Earth, so a place where life could take hold as an analog for processes like that on Mars.
Well, thank you for joining us too. Thank you guys for taking the time out of your day to join us and give us your knowledge and understanding about. So when we're looking at this first image, and this is to either one of you, what is this stretch from the dark areas that are stretching from left to right? What is that and why is it there?
So that big scar, if you will, going across Mars, that is called Valles Marineris, and it is a giant valley on Mars. You can kind of think of it as the Grand Canyon, just supersized. If this valley were on Earth, it would stretch all the way from the Atlantic coast, the Myrtle Beach, South Carolina, where I am, all the way out to California, out to NASA's Jet Propulsion Lab, where they built the rover that's going to Mars. So it is a very, very large valley. How exactly it formed, we don't really know. We have some theories, but there's yeah, it's hard to say. Justin, you want to jump in on this one?
Sure. So the Grand Canyon formed when lots of water flowed and eroded down. And we don't have evidence for that in this area. And especially for something this huge, that would take even more water than form the Grand Canyon. But if you look to the left side, there are those two spots, and actually there's a third one below that and another one off to the side. Those are giant volcanoes. And so the sort of working hypothesis or the working theory of how this formed is as the volcanoes formed, it cracked open Mars just from the amount of lava that was coming out, cracking the surface of Mars. So that's our best sort of guess right now. But we would need to get a rover, like we're sending Perseverance, like Curiosity, down into those to explore the sediments and the rocks in that area.
Awesome. Awesome. Let's go ahead and go on to the next slide and take a look and see. We've got questions. We have questions for our scientists, but you all may as well. So please post your questions either in the chat or the Q&A. If the chat gets really busy, we'd like them in the Q&A section. So Sherelle, please take it away.
Awesome. So as we're looking at this map here, why is the turquoise dot where Perseverance is projected to land, why is that so important? Why is that area so important, especially when there's another name right beside it? Why is that area so important for us to land there?
So Perseverance, and we'll see on a couple slides up, is going to land in Jezero crater. And this is where a rock slammed into the surface of Mars and created a bowl. And one of the cool things about Jezero is on one side of it, you can see what looks like a fan, sort of like Louisiana, where you've got a fan moving out. And this is where past water flowed into Jezero crater. So we'll see this later. But this is one of the reasons that Perseverance is landing there, is for evidence of water in Mars's past.
Did you say water?
I did. So this is one of the driving things, and you can see Viking, Pathfinder, Opportunity, Perseverance, Curiosity, and Spirit are all right around the equator. And one of the reasons for this is where the south half of Mars is very high, the north half of Mars is very low, and this is where water probably once flowed from one side to the other. And so this is why we keep sending rovers to this area. And as Christine pointed out, the feature we were looking at on the last slide, you can now see the 4 volcanoes and that giant crack in Mars.
And it looks like,
go ahead, Christine.
Please go back to that picture for just a second. And Sherelle, I'm sorry, continue.
Now, I just wanted to highlight a comment, and it comes from Jonathan, and he just want to know, how big is Mars? I guess if comparison to Earth, how big is Mars?
So Mars is a lot smaller than Earth. It's about a quarter the size of Earth, and it has a lot of the same features on the surface and a lot of the same types of rocks on sort of a large scale, but once you get down to sort of the details like size and the certain types of rocks that are on the surface and within certain regions, they are very different. But yeah, it is a bit smaller than Earth. Not as small as Mercury though, but smaller than Earth.
Okay, I have another question. It comes from a house question from my house. They want to know, if Earth year is 365 days, how many days would equal one Mars year?
So because Mars is farther away from the sun than Earth is, it takes longer to go around the sun once, right? And that's how we measure a year. I forget the exact number, but I want to say it's like 620 or 650 days is a a Mars year. It's not quite double what an Earth year is.
Wow, that's still incredible though. Like you think about waiting at least 600 days until you had a birthday.
That's just what I was going to say. You have to wait twice as long for your birthday to come around. That kind of stinks.
It does.
It does.
There was a question asking to us to compare Mars to Earth's moon. So if the Earth's moon, you can fit like 4 Earth moons across the Earth. If you can fit 4 moons across the Earth, you can fit, is it 3 Marses? I think 3 Marses across the Earth. I think it's about a third. Is that about right?
I think so. I think that sounds about right. Yeah.
So it's a little bit bigger than the moon. Let's go on to the next slide. Let's get going here. We got lots of stuff to look at. Yay. So next slide. And Dr. Craig, would you mind telling us a little bit about the Mars 2020 rover and mission here and what this is?
Sure. So this is an image of what we call the back shell, which is that sort of dome-looking thing on the left, and the heat shield, which is that bowl-looking thing on the right. And a lot of people don't really realize just how big this rover is. Perseverance is the largest rover that we've sent to another planet to date. And you can see just behind the back shell there's people standing there. They're all dressed in white, they're all covered up because we don't want pieces from our Earth, from our world, to contaminate the rover, with hair, skin cells, our fingerprints, that kind of thing. So this is just to kind of give you a scale of just how big this rover is. It's the size of a small SUV. And that heat shield there is going to protect it from the intense heat as it goes from space into the Martian atmosphere. And then the back shell there is basically what houses the rover during entry. So once we get to a certain point in the atmosphere, that back shell will be blown off, it'll fly away, and then eventually the rover will come out of the back shell and land safely on the surface.
Awesome. Thank you. Let's go on to the next slide. And Justin, do you want to talk a little bit here about this, what Patricia was just saying here?
Sure. This is a cartoon of what's called the 7 minutes of terror. This is the landing of Perseverance, and it follows very similar to the landing of Curiosity. So you can see as it comes through, the first thing that will come off is that bottom heat shield as the parachute opens. The radar will then lock with the ground. So even though it's floating through the atmosphere, it will actually start pinging the ground to find out how far away it is. As it gets close enough, the rockets will actually propel it to the ground as the back shell and the parachute comes off. And then in the final stage, it will actually winch itself down to the ground, land, and then once it does, this thing called the sky crane will blow away so that it doesn't land on top of Perseverance.
Oh, that would be horrible if it crashed on top of it. There's a question here. How many days left before this landing happens? So tell us a little bit more about when it's going to happen. And and then we can address a little bit of this with the next picture too. So
we are 5 days from landing now.
So it's going to
so very soon.
Very, very soon. It left Earth back in July. Yeah. Okay. Next picture. Let's take a look here. Justin and Patricia, would either of you like to talk a little bit about this picture from the Curiosity rover?
This is one of my favorite images. So this shows Curiosity landing, and it's actually taken with the Mars Reconnaissance Orbiter. So we have so many missions on Mars that they can take pictures of each other as they're going through this. And the image is so clear that you can see the cross on the back of the parachute. You can see that back shell that Dr. Craig was talking about as Curiosity is floating down towards the surface in Jezero. So this is one of my favorites.
Awesome, awesome. We've got some questions appearing that I'm going to let our speakers actually just type in the answers to a couple of these. But I think, and there's questions that we're going to tackle. Thank you for those of you who have asked questions about the helicopter and about our search for life. We'll get to those, I promise.
Well, before we move on, I would like to know, how are these images captured? Can we talk about that?
So this particular one was like Dr. Filiberto said, was taken by the Mars Reconnaissance Orbiter by a camera that's actually mounted on the orbiter. So if you go to like Google Earth, you see all these sort of aerial views of features and places on Earth. Well, we have satellites going around Earth, and they have cameras, and they're taking pictures constantly of our surface. We have a similar setup, not as many satellites around Mars, but doing the same type thing. And a lot of times we can get, I think it's on the high-rise camera, that we can get down to like 12 inches or so per pixel. We can see things that are only, yay big. So very, very high resolution images that we can get. We don't always take that high resolution, because that's a lot of data to have to send back to Earth. But when we're talking about trying to choose a landing site for a rover, or after the rover has landed, trying to figure out where to drive, those cameras on those orbiters go a long way to helping us figure out, which direction we should go, what points might look interesting, that kind of thing.
Awesome. Thank you. We haven't talked about the rover yet. Let's go on and let's get talking about where it's going to land and what we're going to see. Sherelle, what questions do you have for our speakers here?
Well, if from another question from home, why are there different colors there? And is the image indication of water? Is the questions from the kiddos here.
So Mars is not this colorful, sadly. This image has been altered to highlight certain types of rocks that we can see from orbit, and that we are expecting to investigate more closely once we get on the ground. So this is like what Dr. Filiberto was talking about earlier. It's called a fluvial fan, where just like the Mississippi Delta or the Nile Delta, you have a river that's coming into a large body of water, and it fans out and it dumps everything that it was carrying into this body of water. So this is what we see in Jezero Crater, and this is one of the reasons why we chose to land there. These different colors have been assigned to different rock types, and if I'm not mistaken, the blue and green colors there indicate minerals that form in the presence of water. So we know that water is required for these minerals to form, and so this is really strong evidence that water was here at some point in Mars history.
Thank you. Dr. Filiberto, do you want to tell us just a tiny bit more what people are seeing? Because most people aren't familiar with satellite images, right? So most people won't know what to make of this. Can you tell us a little bit about what we're seeing here, what these shapes are?
Yeah, so we're looking at the edge of the crater. So at the top of your screen, I realize you can't see my mouse, but at the top of your screen, that's the rim of the crater. And right in the middle, there's a breach with that straight thing coming straight down. And that's where Dr. Craig was talking about the fan. The water came from there. And then this piece at the bottom is where it all dumped out. And so you're looking sort of like you were looking over the top of Mississippi, the Mississippi Delta, looking at the fan. There's 3 or 4 large sort of bowl-shaped things within this. These are actually smaller impact craters within this that have then, after this fan came and was deposited, came and smashed into the surface. And so we can see lots of different rock types, as Dr. Craig was talking about. We can see different ages. So the fan had the large crater happened first, then it filled with water. We had this fan deposit, it dried out, and then we had all of these smaller impact craters happen later. So lots of different things happening and lots of things to explore.
There's a question right now here about craters, and that is how big or small can a crater get? And I also wanted to kind of mention, so the ripples that we're seeing here that kind of almost look like water aren't water, are they? You want to, do either of you want to tell us answers to either of those two questions?
So the ripples that you're seeing are sand. That's as wind blows the sand around, just like if you were in the African desert, you would see sort of sand dunes moving around. So this is a very sandy area, which is going to be fun and challenging for engineering and driving around this area to get to where we want to see.
Awesome. And the question about how big or how small craters can be. Dr. Craig, do you want to tackle that? How big or how small can a crater be? Let's say on Mars. Or
Yeah, so the limiting factor of how big a crater can be is how big the object that hits it is. As I'm sure you all have seen, especially like in movies and whatnot, if an asteroid is coming towards Earth, once it enters the Earth's atmosphere, it starts to heat up, right, as it gets into our atmosphere. And that heat can break the rock apart. It can break it into smaller pieces, that kind of thing. So there has to be sort of it has to be so big in order to survive to the ground. On Mars, however, there's a lot less atmosphere to break up those types of rocks and asteroids. So you can get a lot smaller things coming down and reaching the surface. We've seen craters on the order of, maybe 10 or 12 feet in diameter on Mars. We've also seen things like Hellas Basin, which is a huge giant impact, several thousands of miles across. So it really kind of depends on, where you are. In this image here, that really circular crater that's kind of, prominent just to the left of center in the fan is about 1.5 miles across. So just to kind of give you a scale of how big an image we're talking about here.
So we've got lots of questions that we'll tackle for some of these others. One last question for the picture with the colors, though. Someone wanted to know, what color is clay? Is clay a particular color here? And
if I'm not mistaken, the pinkish, Dr. Craig, you can correct me if I'm wrong, but there's clay deposits within the fan.
Right. That's my recollection. The pink and kind of the orange areas are the clay minerals.
okay. And in the chat, I'll see if either of you are able to answer the question about BVI and HDD capabilities. Let's go ahead and continue moving on, though. Thank you. So here it is. Here's the rover. Should we do let's do a poll question here, shall we, Sherelle? Michelle, let's go ahead and do our poll question here about the rover. Yeah. So what are the rover and Ingenuity Helicopter going to do on Mars? You can answer multiple choices here, everyone. So they're going to study the rocks. For those of you joining us on YouTube, here are the choices, because we recognize that you can't see them. Are we going to be studying the rocks? Are we going to be planting potatoes to grow? Are we going to be looking for signs of ancient life? Are we going to collect samples of Mars rock and soil? Are we going to study the weather and climate of Mars? Are we going to create breathable air for us? Are we going to test technologies for future missions? Are we going to talk with aliens? So what are the rover and helicopter going to do on Mars? Go ahead. We're going to give you 5 more seconds to finish answering. 4, you can pick multiple answers. 3, and 2, and 1, and let's go ahead and let's see what everybody voted for. Woo! Dr. Filiberto, which of these answers is correct? Let's bring it back up again so we can see it one more time. So what are we going to be doing with the rover and with the helicopter?
I'm glad no one said talking to aliens or planting potatoes to grow, because we are definitely not doing those. We are definitely going there to study rocks, so I'm glad to see so many of you choosing that. We are collecting samples of rocks on Mars. This is the first mission in a series of missions to actually bring the samples from Mars to Earth for the first time to actually study them. We will be looking for signs of ancient life. We will study climate and weather and climate, sorry. And we are testing technologies for future missions, which actually goes back to the one before that, in the benchtop of the rover. So in the body of the rover, we're going to be testing to see if we can pull oxygen from the atmosphere for future missions.
Thank you. Sherelle, I'm sure you've got lots of questions here.
Yeah, I'm just blown away about pulling oxygen from the atmosphere. Could you even start to speak about how that process is even done? And there's also a question, why do they use a purple light? You can also drop that one in as well. That was from Aaron. Thank you, Aaron.
So I'll start on the making oxygen. Mars atmosphere is mostly carbon dioxide. So it's 1 part carbon, 2 parts oxygen. What this instrument is called MOXIE on the rover will do is actually pull the oxygen off that carbon and create O2, an oxygen molecule similar to what we have here on Earth. Now, it's not going to make the entire atmosphere breathable, but the idea here is to generate, instead of having to bring oxygen with us to Mars when we eventually send humans to Mars, because that's extra weight and that means extra money. Instead, we could use the atmosphere once we get there, and sort of use, what Mars has to generate breathable air for astronauts. So the instrument will be doing this on a very, very small scale. Obviously, the rover doesn't need oxygen to breathe. This is doing this, kind of preparing for human exploration. But it's a technology demonstration that they want to, see how it's going to work on Mars, and then use what we learned from that process to improve and make it more efficient for when we actually send humans to Mars.
Thank you. There's been a couple of people asking questions about the purple there, and is that false light, or why would we use purple light? Do either of you want to talk a little bit about some of the different colors of light that we use that we can't see on Mars instruments?
Well, I'm sure everyone on the line here is familiar with a black light, right? That purple light. The rover has an instrument on it called Sherlock, and it's an acronym for something I can't remember what it is, but basically it's going to use purple light to look for certain minerals on inside the rocks, and also look for organic compounds. All life as we know it needs and uses these very large organic molecules to metabolize, to breathe, to basically to live. And so this purple light is a very specialized light that is just outside our visible range, that will help identify those types of things in the rock. And it's really cool that they were able to put it at the end of the arm so that the rover can kind of reach out and get very close to a rock and analyze it, using the arm. We won't have to drive up very close to it.
Thank you. You know what? The next slide, I believe, has a picture of something that the Ingenuity helicopter. And one of the questions earlier that we had from one of the people participating about the helicopter was, how do we make sure that the weather isn't going to destroy it, that there's not going to be a storm that might destroy this helicopter? Justin, Dr. Filiberto, do you want to say anything about winds and storms and using the helicopter?
Sure. So one of the things is we will have a weather station on Curiosity, so we can track the weather. On Perseverance. We also have one on Curiosity, so we can know what the weather is. We can know what the winds are. We also have weather information on Ingenuity to figure out, to sense what's going on. We also have, as we've been talking about, all of these orbiters around Mars that are tracking what's going on, and so we can see dust storms coming. If you've seen The Martian, which is what everyone thinks of when they think of wind and that massive dust storm knocking over the power, Mars has such a thin atmosphere that even in a big sort of dust storm and heavy winds, the wind would feel like a light breeze. It's not like The Martian portrays, where the winds are so strong that things get knocked over. That was Hollywood doing artistic license. Mars has so little atmosphere that while it does have wind, it is not nearly as strong as it comes off.
Awesome. Ms. Sherrill, do we have any other questions for this particular slide, or maybe are we ready to move on to the next one?
I think that we're ready for the next one. Thank you. Oh, Aaron, how does the wind blow? I'm thinking that's what she meant. Can we answer that question?
Wind on Mars works very similar to wind on the Earth, where you've got pressure changes, you've got temperature changes, and so air moves because of that.
And there's a question here about how NASA made the helicopter and what it's made out of. Do either of you know anything about how they made the helicopter or what it's made out of? And how it lifts up? You know what? Let's save some of those questions after this next activity, because the activity afterwards is going to be about helicopters. This next activity, there were some questions about water, and we will get into those questions while we're doing this next activity, I promise you, and the search for life. So let's do that poll. Michelle, there is a poll question, I think, about searching for life. And how can we tell whether something is alive? Because how you know if you found life if you don't know what it is? So we're going to give everyone, let's give them about 15 seconds to answer this. So the choices include: it moves, it breathes, it grows, it burps, it talks, it reproduces, it eats and drinks, it poops. So which of these will help us tell if something is alive? Can you go ahead and select your choices? We're going to give you 10 seconds to finish selecting choices here. 9, 8, 7, 6, 5, 4, 3, 2. Everybody finished checking? 1. Everybody finished checking? And let's go ahead and close it, and let's see what people answered. So we have a lot of great answers here. About half of you said it moves, but we all know that like the wind blows things that aren't alive. So moving isn't always a great way to tell us if something is alive. And plants don't move a whole lot, but they're kind of alive. Breathing is great, right? Because even plants breathe. Everything breathes, and growing is a great one as well. Burping, maybe not so much. It depends. It talks. Not all life talks, though, right? There's a lot of life that doesn't talk. Reproduces is a great one. Eats and drinks is a great one. And poops is a great one. Life poops. So all life poops. We take things in and we take things out. And that even includes little itsy bitsy microbes. So we can go ahead and close that, and let's stop sharing the PowerPoint briefly for this activity, and we are going to share my camera. Michelle, can you go ahead and spotlight my, there we go. So we have an activity here where we are going to be looking at these 3 samples. We've got A and B and C, and in each of these samples, we have some interesting things to look at, and we're going to be looking for evidence of life in each of these, and we want you to tell us a little bit about what we're seeing and what the evidence for life is there. So life as we know it, all life that we've seen seems to need water or some sort of medium like water. So we're going to add water to each of these samples in a minute. And all life as we know it needs a source of energy as well. And sugar is pretty great source of energy here on Earth anyway. So we're going to add sugar and water to each of these and look for evidence of life. I'm going to let you see each of them right now without the sugar and the water. And does anyone have any early suggestions or observations in terms of which one or ones has any evidence for life? A or B or C? You are welcome to enter it into the chat now or in the comments. Do you see any evidence for life in A or B or C right now? Here we have A, B, and C. We've got some soil samples here. What evidence for life do we have for each of these? And what questions do you have about them? So someone said they think they see evidence for life in C. A few of you say you think maybe C might have evidence for life. And yes, you're welcome to type in questions as well. So a few of you think you have evidence for life in C. You are welcome to go ahead and enter in your observations. And while you're doing that, I'm going to enter some sugar. I'm going to add a teaspoon of sugar to each of these. And I'm going to add some nice warm water to each of these. You ready? So I'm going to stir this up a little bit and add some water to A. There's water on A. And are you seeing something here as I added water? Are you seeing any evidence for life there? What are you seeing that might tell you that maybe it may or may not be alive? What are you observing? I'm going to do the same thing for B here. And what are you seeing in B? And I'm going to do the same thing for C here. So earlier, some of you said that you thought that there was evidence for life in C. Do you have any evidence for life now? And if so, in which cup, A, B, or C? Several of you said now that A, and there was a question about sugar. Sugar is an energy source. The sugar represents energy, a source of energy. We all need food to eat and to live. And there's a lot of life that doesn't do a whole lot. So some of you think that maybe it's A, that A is breathing, that maybe A is exhaling. It stopped. We'll give it a few seconds and see what happens. Let's go ahead and let's bring up the slides, and the next slide, while we talk about the conditions for life, we can keep looking at this video while we're doing it, but we'll bring up the next slide here and talk about what life needs. And life needs water or some sort of solvent. Life needs an energy source like food, oxygen, sunlight. So life needs those things. It needs to be able to extract that energy from its environment somehow. So it needs a way to get that energy. What else? It grows or changes. It reproduces. Life releases waste. All life poops. So life needs, it evolves and adapts to its environment. All life does something and keeps doing it. Now, Dr. Craig, I know you've been working a little bit more on astrobiology. Do you have anything here that you want to add to this? Or that you want to mention or to confirm?
Yeah, I mean, this all looks good. The main thing about life is, it intakes nutrients and it expels waste, whether that's breathing or pooping or burping or any of those fun things. One thing that I do want to point out, though, and this is sort of a thought question, everything that we know about life comes from life on Earth. So it's kind of fun to think about. I won't get into this right now, but it's kind of fun to think about what if life did start up somewhere other than Earth? Like, how would it be different? How would it be the same? You know, Mars, we think, was a lot like Earth in the past. So any life that might have developed there would probably be very similar to what we see on Earth. But there are other worlds, like some of the moons of Jupiter and Saturn, that are very different from Earth. And so it's sort of fun to think about how those might be different from life that we know of here on Earth.
Thank you. There were we added water here, and there was a couple of questions earlier about water, and here we just said life needs water. Could we drink the water on Mars? And is the water on Mars any different than the water is on Earth? Is it like a different combination of hydrogen and oxygen? What's the water on Mars like? And would it work for aliens? Would it work for us? Any ideas?
So water, again, as we know it, is, you know, 1 part oxygen, 2 parts hydrogen. Most of the water on Mars is in solid form, right? It's in the form of ice. We see a ton of it at the polar caps, just like we see, you know, here on our Earth, the North and South Pole. We don't have any evidence for liquid water at the surface now. We think there might have been, yeah, at some point in the past, but some other research is going on, again, just like generating oxygen when we get to Mars. Could we make our own water from what is already there on Mars? There's research going on there of how we would access that water that's on Mars, whether it's in the poles or whether it's below the surface, and not have to bring it with us, because again, that's extra weight and that's extra money to have to bring it with us.
Thank you. Thank you. And let's see, there's a couple of other questions. There's a question about how gas poops, how grass poops, how grass releases things. Grass releases waste, right? In terms of exhaling, right? I guess, is it carbon dioxide or oxygen, right? Is the way that, or are there other things? Do either of you know? Because I honestly don't know anything beyond that.
Yeah, I'm not a botanist, but I do know that humans intake oxygen, we exhale carbon dioxide. Plants do just the opposite. They take in carbon dioxide and they exhale oxygen. So that would be a grass's releasing its waste, would be the oxygen that it releases.
Thank you. And Dr. Filiberto, somebody asked a question about water on Mars and asked if it was too hot for water to be on Mars. Dr. Filiberto, can you answer that? And while you're doing that, Michelle, please do go on to the next slide and we'll get started on this last activity.
The issue is partially temperature and partially goes back to how little atmosphere there is on Mars. So any water on Mars right now is frozen. So we have the 2 polar caps. We probably have water frozen underground. So there's no water today, as Dr. Craig said, that's stable on the surface. It wouldn't be flowing. It would be in ice form, what we see.
Awesome, awesome. And we're getting started on our paper helicopter. We will go back to look at those observations in a few minutes. But in the meanwhile, we're getting started here. Sherelle, Miss Sherelle, would you care to talk just for a second about what people are doing here with this piece of paper?
Absolutely. All right, everyone. So I definitely see Miss Sonia and Sabrina and the other name, Dad. I'm just going to say Dad. I see them that they are now cutting out their template. Thank you so much. So for everyone else, if you haven't already done so, Alex, there it goes. I see the name now. So if you haven't already done so, would you please start to cut out your helicopter here? But if you haven't, you can put your piece of paper to the screen and trace out our helicopter template. And guess what, guys? We're gonna test it out. I have some sample helicopters for you, And I've made some modifications to some. This is the one, the original template here. And then I've made some variations of mine as well. So I want to give you just a few seconds to go ahead and cut it out. And then I'll show you the proper way of bending it. And that's going to be on our next slide. So I'm going to have Miss Michelle to keep this up for a few more seconds so you can trace it if you haven't printed it out. And then we're going to bend it to form our helicopter. And then we're going to test it out. How does that sound?
That sounds like a lot of fun. So everyone, if you've got a few more seconds to trace this, if you would like, that we've made it nice and big. Let's go back. Let's stay here. While you're tracing it, we're going to show you all the dotted lines, as Ms. Webb said, need to be cut, and then the solid lines are going to be folded in just a minute. And this activity is related to that helicopter landing on Mars, so that it hasn't taken off yet. But what the Ingenuity helicopter is going to do, it's going to be a technology test, right? Dr. Filiberto, Dr. Craig, do either of you want to say anything about how easy or hard it's going to be for it to fly on Mars, and why would it be easy or hard for a helicopter to fly on Mars?
Well, we've mentioned it a bunch of times that Mars' atmosphere is a lot thinner than Earth's, and in a helicopter on Earth, lift is created by these rotors, kind of slicing through the air. And the more atmosphere you have, the easier it is to get lift from that atmosphere. And on Mars, though, the atmosphere is so much thinner. We have to make other adjustments so that we can get the same type of lift. And the major adjustment that Ingenuity is making is that it is spinning its rotors very, very fast, much faster than any helicopter would need to do here on Earth.
Thank you. Michelle, would you mind stop sharing the PowerPoint for right now so we can all see Sherelle up close while she shows us how to fold our paper helicopters? So we'll take a close-up look. Let's pin Sherelle for everyone. There we go. And she's going to show us how to fold one of these.
All right. So if we have our template, ladies and gentlemen, I am working from just a regular sheet of paper. Ooh,
we're having trouble seeing it, unfortunately. You may need to stop sharing.
Background.
Yeah, I'm sorry. It's a beautiful background. So while she is doing that, she's going to show us how to fold one of these. There we go. We're all working from home today.
Absolutely. All right. So I have my regular sheet of paper here. Now, one of the first cuts, guys, is to make the slit from the top section. Go ahead and make that into 2 halves. And this could be, you can use it like as a propeller. So you have a slit going down the top, the front end, and you're going to simply bend them back like opposite of one another. So
they're going to be folded, but folded enough that they're bending over, but they're not folded all the way so it's flat. Is that right?
Yes, that's correct.
Okay, so go ahead and show the whole thing kind of standing up like that so we can all see it. There we go. So it kind of makes like a floppy T, a floppy letter T.
Exactly. So I have the slit and then one going up one way, the other one is the opposite way. So I can actually do this.
Okay. And let's take a look at how you fold the bottom now too.
All right. And then the bottom half. So there's another slit from this side and this side. And then you're going to start folding one half down, the other one down. So then it's just a straight piece. Okay. This is the top. Yep. So it's a straight piece.
Uh-huh.
And then you want to just fold them over one another. So then you have just a straight piece here. And then lastly, you're going to bend the bottom up.
So, and these are flat. So,
right.
so that bottom piece is nice and flat.
Yep.
And then we saw some people already practicing dropping their helicopters. Is it time to practice?
Sabrina and Sonia and Alex, they are definitely rock stars. Can we highlight? Yes, absolutely. Can we highlight them, please, Michelle?
Awesome. So let's go ahead and let you all show us one more time how they fall and what they look like when they fall.
Sure, it's really fun. 1, 2, 3.
And they're clearly taking a little bit of time before they hit the ground, right? As they're spinning, they're not just immediately dropping, they're kind of floating down, right?
Yeah, they are really slow since they spin.
Awesome. Awesome.
Great
So,
work.
Ms. Sherelle, you have some different helicopters that you've made that you'd like us to make predictions as to which ones are going to work better or worse.
Yes, I do. Thank you for bringing it up.
You're on mute.
Yeah, hold on. Someone is in my area. So thank you. All right. So I've made some modifications, and I'm going to take off the background once again so you can see my okay. So I've made one out of cardboard. So please excuse, I use the template from the taco boxes cardboard. But hey, we're makers, so we making it out of anything. So I use the same design, but this time it's out of cardboard. So I made my flaps here. They're going in opposite directions. And then notice that this part isn't as long. You see that? But then I still made sure that I cuff the bottom. Everyone sees that? So
That looks great. Can we see
my flappy?
Can we see how that one works compared to the other one?
Yeah, awesome. One moment.
So
we're focusing, Miss Michelle, can you highlight the Ingenuity?
There we go. Yep, we can see it. We can see it.
Ready? 5,
Yep.
4, 3, 2, 1.
Oh, that didn't work at all.
No, not at all. All right, and then I want to show you back on my screen, Miss Michelle. So the next one that I've done, guys, I modified. You notice that this is like a tiny one. I thought that, well, you know what? Here's the regular one. So compared to it, it's a lot smaller, but it's of the same material, okay? So I want you to guess, like the first one that Sonia, Miss Sabrina, and Alex made compared to, he said that it was slow coming down. So I want you to guess and see which one will work best, because this is a small one. But let's test it out and see.
Let's take a look. Let's take a look.
All right, in 5, 4.
Let's highlight the other video. There we go. Okay. Sorry. Countdown again. There we go. Oh.
I'll do it again, no worries. 5, 4, 3, 2, 1.
That worked sort of well.
Okay, yes, it worked well. However, I think that the shorter propellers definitely didn't make it successful. And I'm only 4'11", by the way. So it's not like it's coming from a, a higher distance. So I think that the original template is definitely the way to go.
Okay. So folks, you are welcome to practice making your own. The question about what Ingenuity is made out of, to keep it light so that it doesn't crash like that cardboard one, it's mostly made out of aluminum. Let's refocus back on my camera and let's take one last look now at our samples so we can see which one of these might have evidence for life. Earlier you all said C, but now you can see C really hasn't done much of anything. So A fizzed and then it stopped fizzing, and it's kind of just got a little bit of cloudy stuff to it. And B has something different growing on it. Which ones of these has evidence for life now? Which ones of these do you think has evidence for life? Do you think A has evidence for life? It's got a little bit of foam, just a little bit of foam. B, which has a little bit more foam now, and the foam is starting to grow. or C, which kind of just looks like wet sand with a few pieces of white stuff in it. And we've got some of you saying A and B and a lot of you saying B. Remember how we said life does something and keeps doing it? A did something, but then it stopped doing it. B did something and it's still doing it. And C isn't doing much of anything. I should also tell you in terms of temperatures that they're all warm from that hot water. They're all about feeling about the same warmth. A doesn't smell like much of anything. B smells like baking bread. And C smells like sand. So B is growing. Life grows. Excellent job, guys. Let's go ahead and let's bring up the last few slides here. We're out of time. Let's bring up our last few slides. And so we wanted to let you know that if you go to this JPL website, there's a lot of resources there, and that's a great place where you can all go and find activities and ideas as well as the USRA STEM Action Center. So we wanted to let you know about that. Let's continue on to the next slide. And Michelle or Amanda, would you please help us conclude this?
Absolutely. Well, thank you so much, Christine and Sherelle and Dr. Filiberto and Dr. Craig for the really engaging presentation today. I think it was really enjoyable and a lot of good lessons learned. In closing, I just want to thank Lockheed Martin for generously allocating the funding to support our activities throughout the past month, all related to perseverance. Again, just a friendly reminder that next Wednesday, February 17th, we will hold the event in collaboration with the American Museum of Natural History. I would really hate for you all to miss it. It is going to be absolutely phenomenal. And you'll have the opportunity to ask questions to these astronauts. And so, again, please visit our website, USRA STEM Action Center, to gather additional information. And we'll look forward to seeing you then. Also, don't forget to follow us on Facebook. So take care and have a wonderful day.
We have final poll questions. Let's bring up the final poll questions before people leave. We would like to hear from you in terms of some of these final questions. As you're getting ready to leave, let us know a little bit more about today, whether you're more interested in Mars after participating. Did you learn something today? And would you like to attend similar events? We would love to hear more about today and what you think before you leave. So please take just another 15 seconds to answer these poll questions. The first one is, are you more interested in Mars after participating? The second question is, did you learn something today? And the third one is, would you like to attend similar events in the future? We're going to give you 10 more seconds to answer here before you take off. And we're going to give you 5, 4, 3, 2, 1, and we'll close down and lock down the votes. Please join us in thanking our speakers, Dr. Justin Filiberto, Dr. Patricia Craig. Please join me in thanking Sherelle Webb for all of this, Yolanda for helping us make all of this work on YouTube as well. Lisa, thank you for joining and your help with questions and answers. Our families, everyone for participating. We're so glad. Enjoy the next week and join us again on Wednesday and Thursday. Wednesday for the event with Open Space and on Thursday to watch the landing. And let's go ahead and let's stop the live stream. Michelle, can you either make me the host or can you stop the live stream yourself? It's up in the left corner.